Now we are in lesson 2.4. It's operations with functions. We have in this lesson two parts. We have the composition of functions and we have inverse functions. I'll start first with part A, functions composition. What does it mean function composition? How do we find the domain of the function composition? And how do we calculate? First, what does it mean function composition? Function composition is an operation that combines two functions to form a new function. Also, it could be, guys, combination of more than two. It could be three functions. But now we will start with the first example as two functions, then we will move on to the three functions. The notation of the composition functions, we read it, sometimes we say fog and gof. It's F round G. Okay, we read it fog and f of g of x, or also we read it sometimes we say gof, it means g of f of x. How do we calculate that? How do we find this domain? Let's see in the first example. Example 1, okay, if I have the function f of x is defined by, it's a linear function to x minus 1, and I have g of x is equal x squared. First, let's find the domain of f of x and g of x. What's the domain of f of x? Since it is a linear function, so its domain is minus infinity plus infinity. Domain of g, also it's a quadratic, minus infinity plus infinity. Now we're going to calculate the domain of f of g of x. Then you're going to calculate f round g. And you're going to check after the calculation that the domain that we did before calculating this function is the same. The first example is a little bit simple, but the second example will be a little bit more complicated. So I think you will get the idea. If I want to find the domain of f round g of x, I start from in till out. X is related to which function? X is related to g. So I need to look at the domain of definition of g of x. X should verify the domain of g. G is, what is its domain? R. It means x should be, when I say minus 50 plus infinity, it means it's R. It means x should belong to R. So this is the first one. Now, g of x, it is the big X for f. So the variable here should verify, or should be the domain, should verify the domain of f of x. So g of x should belong to what? Also to R. And what is g of x? X squared belongs to R, so it means x belongs to R. What is the intersection of x belongs to R and x belongs to R? It is also x belongs to R. So the domain of f round g of x is R. So here, because it's a simple example and both they have the same domain, so the domain of the composition function will be R. Let's calculate f round g. So f of x equal to x minus 1, g of x is equal x squared. When I want to calculate f of g of x, it means I'm going to replace g of x by its value. So I need to calculate f of what? X squared. And when I say f of x squared, it means I will replace x and f by x squared. If you say, guys, f of 1, you put instead of x1, f of 2 instead of x2. So f of x squared, so now instead of x, what I'm going to put? X squared. So what will be the answer? 2x squared minus 1. And let's check. Is it the domain of f of g of x? R? Yes. This is a quadratic function and its domain is R. So what I did before is right. And what is the range of f round g of x? Also it's R. It's all real numbers. So the domain and the range both are R. I'll do another example and the domain will be more clear in this example. So I have here three functions. F of x is 1 over x, g of x is radical x, and x is x squared minus 1. It's on purpose I gave you three different functions that has different domain of definition. If I look at the first function, it's a fraction. It's a rational function. A fraction is defined when the denominator is not equal to 0. It means my domain of definition is minus infinity 0 union 0 plus infinity. Or also you can write it like this, r minus the singleton 0. You can either write it like this also. Domain of G, it's a radical, so it means under the radical should be bigger or equal than 0, and it should be 0 plus infinity. And the domain of h of x is r, it's a quadratic function, it's minus infinity plus infinity, or also I can write r if I want. Now, I need to find the domain of f round g round h of x. Then I will calculate f round g of h. And then we're going to check that what I did as a domain before doing the calculation is right. So how are we going to find the domain of definition of f of round g of x? I will start from in till out, as I said. X is related to H. So I'm going to take X, what is for the domain for H. H is what? What is its domain? R, it means X should belong to R. Now, H of X, I will take it for the domain of H. H of X should be what? What I said here. What is the domain of G? Let's go back. The domain of G is what? Bigger or equal than 0, isn't it? It means H of X should be bigger or equal than 0. And then G of H of X, all this, it should verify the domain of F. So G of H of X should be what? Not equal to 0. Now I need to find what is the value of X in this and this interval. So I need to solve it. Here it means I need to solve X squared minus 1 bigger or equal than 0. So I need to do the table of sign for this one. And here also, when I say G of H of X, it means it's G of X squared minus 1 should be not equal to 0. It means that radical X squared minus 1 should not be equal to 0. And now I should, guys, find the, do the table of sign for this one, and also find the solution for this one, and then find the intersection of X belongs to R, this one, and this one. So this one I will put 1 here. This is 2. I will do it. Let's do it. How are we gonna solve the inequality X squared minus 1 bigger or equal than 0? This one is a quadratic equation. We know that. And we can either do delta, or I can take one to the other side, so I can solve it equal to 0 to find the roots. And then this one will give me 1 and minus 1. I can do the table of sign, you know that from the preceding chapters. And this is a quadratic equation. How do you do the sign? Same, opposite, same. So plus, minus, plus. So which part I need? The bigger or equal than 0. It means here it will give me minus infinity minus 1 union 1 plus infinity. But the last one, 3, gives me that radical X squared minus 1 should not be equal to 0. It means X squared minus 1 cannot be equal to 0. It means X cannot be equal to 1. And X cannot be equal to minus 1. And now we need to find the intersection of those three. X belongs to R, it means minus infinity plus infinity. X between minus infinity minus 1 and 1 plus infinity, close boundaries, and X not equal to this. What is the intersection of those three? It's very easy. If you cannot see it like this, you can do the number line. Let's do the number line if you cannot see it like this. First, this is the first domain. This is R minus infinity plus infinity. Excellent. I have minus 1 and 1. In this part, I have minus infinity minus 1 union 1 plus infinity. So it means I have this and this with those together. But in the last one, I have X cannot be equal to 1 and X cannot be equal to minus 1. So I need to cancel those two. Those two are not accepted in the last one. So what's going to be the domain of definition in the end? So the domain of F round G round H, I'll write properly, of F, I'll write, sorry, in the French way, it's okay, round G round H of X is equal to what? It's minus infinity minus 1, open boundaries, because X cannot be equal to minus 1, union 1 plus infinity. And now after we're going to calculate it, we're going to check if what I did really is right or wrong. So let's now calculate F round G round H of X. You start all the time from inside. Let's do G of H of X. It means G of X squared minus 1. And then since G of X, it's equal to radical X, so I replace X by X squared minus 1. So this is the function G of H of X. And now I need to find F of G of H of X. It means F of radical X squared minus 1. And instead of X and F, we're going to put radical X squared minus 1. F of X was 1 over X, so that's it. Now, guys, let's check. What is the domain of this one? Isn't it X squared minus 1 strictly positive? It's a fraction. It cannot be equal to, and that is a radical. And this one strictly positive, guys, doesn't give me, look, this is the same table of sign here, minus 1, 1. But here I cannot have those. Same, opposite, same. So isn't minus infinity minus 1 union 1 plus infinity? Yeah, it's, if I want to check it, Yes, it is minus infinity minus 1 union 1 plus infinity. So it means that what I did before, what I did before, guys, for the domain is all right. Now, what is the range of this composite function? What is the range? We can see that since one is positive and radical is positive, so I'm 100% sure that the range will be strictly positive. It cannot also be equal to 0. So what is the range of this function? The range of this function is y strictly positive. Now let's move to the last remark in this lesson. That's it. So we say that f is an identity function if f doesn't change a function g when it is composed with it. What does it mean? So if I do, guys, f round g of x, and it gives me the same answer as g round f of x, and both will give me g of x, so I have the same function g, it means that f of x is called an identity function. And the identity function for those functions is y equal to x. So as I'm doing the composition with x. So again, as I said, and I say every time that you're going to do more practice in the class, the composite function is very easy. You just need to know first how to find the domain of definition. We go from in till out, as I did before, from in till out, and then I find the intersection of the three domains that I did here, and then we can calculate and we can check our domain of definition using the calculation. Sometimes, guys, you have to find the domain before doing the calculation. So you cannot tell me, Miss, why I will calculate and then I will find the domain. No, sometimes I can ask you, find the domain and then calculate the composite function. So that's it. The second part will be about inverse functions. You'll see it in the second video. Don't forget, guys, to like, subscribe, and share my channel. And we will see you next time in the second video.